Hi, class. So this is to go over what we do after an ANOVA test. So what we do is if we reject the null hypothesis that the means are equal in an ANOVA test, then the next question is, okay, well, which one is different and which one is larger, which one's bigger, what if their means are truly different, then which one is different and which one is larger and which one is smaller and whatnot. So to find that information out, we use a test called Tukey's test. And I'm just going to show you how to read the outputs from the calculator, and we won't worry about inputting the data into the calculator so much for this particular portion. But a dentist is trying to decide which materials to use for dental procedures. There's a problem with the example of Tukey's test. He has collected the data below to help him compare the shear bond strength of different materials. So like he wants to make like replacement teeth and like crowns and like fake teeth, and he wants to find the strongest material so that it does not fall apart, right? So he's comparing the strength of these 4 different materials: cojet, silister, Simara, and ceramic repair. Okay, so he enters all this information into the ANOVA test, and he finds the mean of one of these, or he finds that we reject the null hypothesis in the ANOVA test. So that means there's evidence that there's at least one of those means is different. But which one and which material is the strongest? So to find these things out, we run the Tukey's test. So we only do Tukey's test if we reject the null hypothesis in the ANOVA test. Otherwise, there's no point to it, right? Because we believe they're all the same. Okay, so next, here is what they did is they did the ANOVA test already, and now they're doing this Tukey's test, and they found this using a program called Minitab. You may use that in the future. It's kind of similar to some of the computer and Excel and other statistical programs, but it gives you a printout like we see below, and I want you to understand how to read this printout. So what Tukey's test does is they compare every set of 2 materials. So the first one here, and they create a confidence interval for the differences between the means. So between cojet and silister, they are 95% confidence, the 95% confidence interval, that the difference between the means is between, and they give you a lower bound, negative 4.024 and 1.360. So since 0 is contained in that interval, 0 is an expected mean to find when we subtract the 2 means of these 2 values. So that means that the true difference between the means in the whole population is likely to be 0, because we're 95% confident that it's in that range and 0 is in that range. So we're 95% confident that 0 or a number really close to 0 is the difference between those 2, between the mean of the coset population and the mean of the silister population. I'm not talking about just this sample, but if we did lots and lots of other samples, then we found the actual population mean that that mean would be between -4 and 1.3, as we see here. And then, and then also you can see they put a little parenthesis right where the -4 is, and they put another little parenthesis on the other side where the 1.3 is. And so you can see that the 0, where it's marked on the number line below, you can either see You can read for the lower bound and upper bound of the confidence interval to figure out if 0 is in it, or an even easier way is using the graph that they've graphed to the side. So see how they put the little parenthesis right where like -4.024 is, and then they put a negative the parenthesis here right where 1.3 is on the number line. Oh, the center is 1.3, the upper is 6.7. I'm sorry, this is actually 6.7. That makes my numbers okay. Sorry. So this is the lower, center, upper. So clearly we have that the 0, which is located here on the number line, is inside these bounds, you know? So it is a likely difference between the two means. And if we think that the difference between, you know, Coget and Silister, if it's likely that 0 is the difference, then that means that those two are equal. If their difference is likely 0, that means most likely those two means are equal. So from this information, just this first line here, I would say that I know that Coget, because they did Coget subtracted from Silister. So they actually it's the opposite of what I wrote down there. It's Coget is subtracted from Silister, okay? And so that we got 0 is a likely answer for that. So that means that Silister and has a mean that's equal to population mean, right? That's equal, probably most likely equal to the Coget mean. Okay, well, let's look at the next one. They are comparing Coget subtracted from SIMAR, and this line of data is describing the differences, likely population difference between these two. So notice how 0, which is right here, is not in, it's almost in that interval, but it's not in that interval. So that means that these two means are not believed to be equal, because we are 95% confident that the population mean for between of the difference between SIMAR and Coget, that we're pretty confident that it's going to be between negative 11.0 and negative 0.256, but that does not, in between those two numbers, there is no 0. So that means we're pretty confident that the difference between those is not 0. If it's not 0, then they're not equal to each other. So we would say we think that Coget, the mean of Coget, is not equal to the mean of SIMAR. Okay. And then now we're going to look at this last one here, and my is Coget subtracted from ceramic repair. And they said we're 95% confident that the mean is between -10 and -0.11. And when you look at that on the number line, this 0 does not fall between those two endpoints. So we say that when we subtracted those two, and we're 95% confident that basically when we subtract them, the answer would not be 0. So that means that these means are not equal. So Coget does not equal the mean of the ceramic. And we can even, in both of these situations, when we say that they're not equal, you can even go further. Now, if 0 is not in the interval, that means the interval is completely negative or completely positive. And both of these intervals are completely negative. So that means that we took Siramar and subtracted Courgette, because that's what we did. We took a Siramar, Courgette is subtracted from Siramar. So Siramar minus Courgette, and we got a negative answer. So that means that the Courgette is larger than Siramar. So we could even deduct that. Courgette is larger than Siramar, because the differences they predicted would be negative when we did this calculation. And the same thing we can look at between Courgette and ceramic. Their differences, we're 95% confident that those are negative. So when we took the population mean of ceramic and we subtracted Courgette, we were confident that it was not equal to 0, but we were actually confident that it was negative. Since it's negative, it means we were subtracting a larger number from a smaller positive number. So Courgette, the mean of Courgette, is actually larger than the mean of ceramic. Okay, so that is what's going on here. And so it's a lot of information that we're just learning, and so like we could, in this first section, we took Courgette and we compared them to all the rest. Now we're going to take Silister and compare them to the other two. We already compared it to Courgette, but now we're going to compare it to the other two that are left. They call this pairwise comparisons, when you take every single pair of, in this case, different materials used to fix dental repair, our Courgette, Silister, Silamar, and ceramic repair. And you pair each of them and then compare the differences like this. They call it pairwise comparisons. So let's look at the next data. Now let's look down here. We're going to compare Silister to Simara in this first line here. So that means they took the mean of Silister subtracted from Simara. So it's Simara, like mu of CI minus mu of SI. By the way, mu of CI is the mean of the Simara values, and then mu of SI is the mean of Silister values, population mean, right? We subtracted those, and this is the interval that was a result. And notice that 0 is over here, so 0 is not contained in that interval. So that tells us these two are not equal. So we can write CI is not equal to USI. And furthermore, we could say that it's all negative. So we believe that Silister, so they subtracted those two and they got a negative answer. So we believe that Silister is larger than Samara. Okay. Then with the next step, we can compare Silister. Now going on to the next line here. Now I'm focused on just this line right here. And we're comparing Silister to ceramic. And the way we would do that is they took Silister, subtract the means of Silister and subtract it from the ceramic. So the mean of the ceramic minus the mean of the Silister. And this is, they calculated, they're doing a confidence interval to find the population mean, the population differences between the two population means. And what they get is they get that it's negative. So, and it does not contain 0. That's a big, huge thing. It does not contain 0. So that means they're not equal. But then it also means that because the whole interval is negative again, it's all this interval focused on right here does not have the red line crossing through it. So it does not have 0 in there, but it's also all negative. And we can just see from the graph here, because it's below this little part starts below 0 and it goes from above negative or below -7. So, but they actually give you the lower bounds and upper bounds. And that's nice because if it's sort of close to 0, you can kind of tell if 0 is contained there. So they don't equal. And not only that, but when we did the subtraction, we got a negative answer. So because all of the numbers on this interval are negative, so we believe the differences are negative. So that means that the mean of SI is larger than the mean of the CE. Okay, so that's what we get from that. The last one, we compare Samara to the ceramic, and they subtracted Samara from ceramic, so it's mu of CE minus mu of Samara, and they noticed that 0 does lie between those two parentheses, so it is in the interval. So that means that they, they created a confidence interval, and they said we're 95% confident that the true difference between the population means of the ceramic and Samara is between this -5.2 and +5.2, which does contain 0. So there is a high likelihood that when we subtract the population means, when you subtract them, they are 0. So that means the two means are equal. And there you go. So that's the information that we can gain from looking at these results. So let's go to the next page and kind of we can summarize some of the data. I'm not going to summarize which one's larger than the others so much, but I will just focus on which ones are equal and which ones are not equal. So let's go to the next page. So I just wrote this out to help you guys but here at the bottom is how they like to write it. We said earlier that the mean of the courgette was equal to the mean of the Silomar, just double checking, because the courgette and Silomar contain 0 in that interval. And then we also said that the Silister wasn't equal to the Samara or Samaric. So Silister was not equal to, Silister is not equal to Samaric or Samar. And then the last one, the Samar and Samaric and ceramic, they do contain 0. So we think the Samar and ceramic are equal. So Samar and ceramic, they're equal. So this is what how they kind of write it. So we know that the courgette and the Silomar were equal. We believe they had equal means, and we believed that the Samar and the ceramic were equal means as well, but they just did not equal each other. And again, we're just focused here on whether they're equal or not. You can, we could have written more information about which one's larger and whatnot, but I just won't focus on that. But right now, I just want to let you know that a common practice is instead of writing these equal signs, just a little easier and faster if we write a line under the ones that are equal. So they'll just write out all the means, and then if there's 2 that are equal, they'll write a long line under both of them. Okay. And if they all were equal, then we'd write a really long line. But of course, we would not be doing Tukey's test if they all were equal, because however, I will say that the ANOVA test is a stronger test. So it could be possible that you reject an hypothesis that means are equal, and then Tukey's test says the means are equal. because there could be a type 1 or type 2 error in the Tukey's test. So let's just be cautious about that. It says so here's some cautions. Sometimes the results of Tukey's tests are ambiguous. That means they don't really result to anything. They can't really tell us anything. And that's because some kind of type 1 or type 2 error happened, or a type 2 error. Okay, it's type 2, type 1, not type 1. But anyway, so sometimes the results of the Tukey's tests are ambiguous. Suppose the null hypothesis of these 4 means is rejected, and the results of Tukey's tests indicate the following. So let's say that we compared 1 and 2 and 3, and those were all equal to each other. And then we compared 3 and 4, and 3 and 4 were actually equal to each other. But then 4 was not equal to 2 or 1. And you're like, wait a second, well, if 3 is equal to 2 and 3 is equal to 4, doesn't that mean 2 is equal to 4? And that is the correct thinking. So this is like, this is flawed. There's a problem with this. This can't be possible. I can't have 3 be equal to 4, but then 4 not equal, and 3 be equal to 2, but 2 not equal to 4. So if you have a result like this, then you just say the results are ambiguous, or but we don't have we don't have conclusive results from this. And it means a type 2 error was committed by this test. And it can also happen, they say that one way it rejects the fact they're all equal, but Tukey's test does not detect any pairwise differences, like I said. So this is Tukey's test, and I hope that you found it very helpful. Let me go back up one screen, and I'm going to summarize how you interpret the data. So basically, if the interval contains 0, you're going to look at the 2 means that are being subtracted. And if the interval there contains 0, then that means the 2 means are likely, the strong evidence suggests at least, that the 2 means are equal. And we usually draw a line under them to show that they're equal. If the interval does not contain 0, then the evidence suggests the 2 means are different. And then if we look closer at that interval, if that interval contains only negative numbers, then it means that the one that we were subtracting was the larger mean. And if the interval contains only positive numbers, then the mean that was being subtracted was smaller. Okay. All right, well, I hope that you find this information easy and useful, and have a great day. Bye.